Okay, so we want to start things off this morning by just going through some of the very foundational concepts in Python. And I'm going to walk through several of those in this first lesson and also show you a few of the nice shortcuts that we have to save us time when we're using Jupyter. So I want to start by talking about expressions. And an expression is really just a line of code that is evaluated by Python. So uh, the simplest expression might be just a number. So I could write 2020, for example, and execute that cell with Shift Enter. And you can see the output will show me what Python has evaluated that expression to. Now, that wasn't a very interesting expression. Obviously, it's just a number, but we can use expressions to build mathematical expressions to use Python as sort of a calculator. So for example, we can do addition with the plus sign, 2020 plus 20. And then if I push Shift Enter, Python will evaluate that to 2040. Python has most of the mathematical operators in it that you would expect. So we can do subtraction with 2040 minus 20. We can do multiplication with an asterisk. So if I type 2 asterisk 2 and execute that, I get 4. Division with the slash sign, 4/2 gives me 2. And I should also note that Python respects the order of operations. So for example, if I were to type 2 asterisk and then in parentheses 3 plus 2, and I hit Shift Enter to evaluate that, Python will evaluate this to 10. So it will follow what we would expect if we were writing that out by hand. Python has a number of other built-in operators. I will just touch on a couple of other ones that we don't use as frequently. But so I mentioned a moment ago, there's normal division, or what's called true division with a slash. There's also two other types of division. One is called floor division, which gives you the whole number division. So for example, if I do 10//6 and I execute that, this returns 1 because 6 goes into 10 one time, and then there's a remainder. If I wanted to get the remainder, I could use something called the modulo operator, which is given by a percent sign. So 10% 6, and that would give me 4 as the remainder. So we don't use these too often, but they can occasionally be useful for certain kinds of logic. And then finally, if we want to take an exponent in Python, we use 2 asterisks. So for example, if I want to calculate 2 squared, I can say 2 asterisk asterisk 2 and evaluate with Shift Enter to get 4. This one trips up some new users of Python because we do not use the caret key. We use these double asterisks. So those are basic expressions. And typically what we do with an expression is assign it to a variable so that we can do something useful with it. A variable is just a place to store information, and they're given text names. So for example, I could define a variable age, and I could assign a value to it. So we say that when we use an equal sign, we are assigning the value on the right to the variable name on the left. So I can say age equal 30, and that assigns the value of 30 to the variable age. Now, when I execute that cell, I don't get any output because all that's happening is that Python is storing that value. But I can retrieve the value of the variable by just typing its name again. If I type age and execute that, Python will then show me that value 30 that I stored there. Now, each variable has a type associated with it that defines what sort of data it is storing. So a couple of common types are things like strings, integers, and floating point numbers. And one of the nice things about Python is that when you declare a variable, you don't have to declare upfront what type it is. Python figures that out based on what you put in. So for example, just to continue this example above, I assigned the number 30 to age. We can check its type with a built-in function called type. So type, open parentheses. And then if I put that variable name age into this function and execute with Shift Enter, you'll see I get this output int, which is short for integer. So Python is telling me that the age variable has an integer type. And we're going to talk more about how functions work in a few minutes. So just follow along with me there, and I'll explain function syntax in more detail soon. But there are other types that we can define. So a very frequently used one, of course, is a floating point number. So if I wanted age to be a floating point number instead of an integer, I could just assign a value with a decimal point. So I could type age equals 30.0, for example, and then check its type with that type function. And this time age is a float, a floating point number. So Python has just inferred that from the fact that I included a decimal point when I defined the variable. We can also store strings. A string is just text. So for example, I could define this variable my name equals, and to declare a string, we're going to use quotation marks. Now in Python, you can use either single or double quotes. It doesn't matter. So I'll say my name equals Ryan in quotation marks and execute that cell with Shift Enter. And now I'll check its type. Now I'll show you a trick here called tab completion. So you notice this variable name, my name, it's not that long, but maybe I'm a little bit lazy. Maybe I don't want to type. So if I start typing my underscore and then I push tab in Jupyter Notebook, the Jupyter will automatically complete the name of that variable for me. And then I can execute my cell. So that's just it's a time-saving shortcut. And I would encourage you, as you're getting comfortable in Jupyter, to just try pushing tab sometimes while you're in the middle of typing a function name or a variable name. And I think you'll very quickly see how that can save you time. So anyway, we can see that this my name variable has a string type, as we'd expect. Now, I'll also note that it's possible to store numbers as strings. So for example, I could define a new variable called middle age, and I could give that the string value of 35 enclosed in quotes. And if I were to check its type, you'll see that that's a string, even though it looks like a number. So it's very important to keep track of what type of variable you're dealing with, because sometimes appearances can be deceiving. Now, I've already illustrated this, but I want to call special attention to it. Once you define a variable, you can update its value by reassigning something to it. So earlier in this lesson, I defined this variable age, and I'm going to type its name here and execute the cell. We can see that it now has the value 30.0, but I can assign a different value to it. So I can type its name again. I can say age equals 35, and then execute with Shift Enter and look at its value again, and you can see that its value has changed to 35. So once you declare a variable, you can reassign to it to update its value. All right, let's move on and talk a little bit about functions. So functions are very, very useful and versatile pieces of Python, and they all have a common syntax where there is a function name followed by parentheses, which enclose arguments. So one of the most widely used functions that you'll encounter is the print statement. So if I type print and then open and close parentheses, whatever I pass into this print function will be returned as a string. So I could just type a string directly here. I can say my name is Ryan, and I can execute that with Shift Enter, and you can see I'll get this output as a string. I could also pass in a variable name. So print age, and I get the value of age. I can also pass multiple arguments to print, separated by commas. So in Python, when you have multiple arguments to a function, you separate them with commas. So I could define my own string and say my age is, and I'll surround that with quotes because I'm defining that as a string here. Then I'll say comma, and I will now type the name of the variable age, and you can see when I execute that, Python concatenates all of those together and gives me string output. Now, there are a lot of functions in Python, and it's impossible to know what they all do and what the arguments are for all of them. So it's really important to learn how to find help. And there are a couple of very easy ways to do that within Jupyter. The first one is to use Shift-Tab. So after I have typed the name of a function here, print, if I click my mouse inside that function name so that the cursor is inside the function name, and I press Shift-Tab, I'll get this pop-up here in Jupyter that will give me what's called the doc string of the function, or the short documentation of that function. And this gives you an indication of what types of arguments the function will take. Another way to get that same information is to use the help function. So if I type HELP, open parentheses, this itself is a function, but its argument is going to be the name of the function that I want help on. So in this case, I'm going to type print as the argument to this help function and push Shift Enter. And here you can see my output prints out that doc string. So those are just a couple of ways that if you're working with a new function or an unfamiliar function, you can learn what it does. There's also a shorthand way to do this help print, and that is to type the name of the function followed by a question mark. So if you type print question mark, you will get yet another representation of that doc string. Now, print and type and help are what we call built-in functions. They are distributed with Python. They're there by default, but oftentimes we want to make use of other functions that have more specialized functionality. And to do that, we have to import. So I'm going to use an example of a mathematical function. So this comes from a separate piece of Python called the math module. And if I want functions from the math module, I have to say import space math, where math here is the name of this module. So if I execute this import statement, this brings all of the functions in the math module into my current notebook, or namespace as we call it, so that I can use them. And now I can call a function, and I'm going to call the sign function. So first I type the name of the module, in this case that's math. Then I type dot function name, and in this case the name of the function is sign, and it just takes a numerical argument. And I can execute that, and you can see that that does in fact give me a value, so that executes correctly. I'm going to restart my kernel quickly to show you an error that you will commonly encounter. If you were to try to execute this sign function from the math module without importing the library, you'd get an error message. You see, if I push Shift Enter on this cell now, it says name math is not defined. And that's basically telling me that Python doesn't know what this name math means. So that's why you have to do the import statement first, and then once you've imported the module, then you can call its functions. Now, just very quickly in closing, I'm just going to show a quick demo of some of the powerful things that we can do with external libraries. Now, I'm not going to walk through every step of this code here, but what I'm going to do is just show you how we can use a couple of very commonly used external modules. One is called NumPy for mathematical functions, and one's called matplotlib for plotting. And we can use those to make a nice looking plot. So I'm going to import this NumPy module, and I'm going to import a plotting function from matplotlib. Oops. And I'm going to copy and paste a little bit of code from the lesson plan here. What I'm doing here is assigning, I was creating a variable called inflammation, and I am using this load_txt function from the NumPy library to load some data that's distributed in a CSV file here. And then I'm going to compute the average of it and show a plot. And again, I don't expect you all at this stage to understand what every line of this does. But mainly I want to show the result. Let's see, I have a typo. So you can see in executing this, I got an import error on this second line of my code where I said from matplotlib import pylot, and that's because I made a typo in the name of that module. So if I correct that to pyplot, this should work well. All right, and so we execute this and we get this nice plot. So again, I show this as an example of the kind of specialized functionality that you can bring into Python by importing third-party modules. So this was a quick overview of expressions and variables and built-in functions in Python. And I want to pause here and flip over to the exercises and invite you guys to work your way through some of these exercises that we have. So I'm going to show each exercise on the screen here, and I'll give you just a minute or two to go through each one, and then we'll talk about the solutions together. So in this first exercise, we are considering different types that we might encounter in Python. So I've shown 4 different variables here, and simply by inspection, take a look at these and see if you can tell what the type of each one is. And I'll just pause for 30 seconds or so while you guys think about that. All right, so var1 here is assigned the value of 1. Now you notice that there is no decimal point around 1, and so that is going to be a string type. Excuse me, an integer type. var2, we've assigned the value 1, but this time there's a decimal point after the 1. And so that is going to be interpreted by Python as a float. var3, I think, is pretty straightforward. You'll notice the double quotes and you notice the text. So that is going to be a string. And then finally, var4, it is a number, but you'll notice that it's surrounded by double quotes. So that is also a string. So hopefully that was an easy warm-up exercise for everyone. So next exercise here, I have given you some code to define a variable called mystery. And I want you to use a built-in function to determine the type of this variable mystery. So I'll just pause for a moment and let you guys work on that. All right, so I'm going to start by copying this example code so that I can declare this variable mystery. Just paste that into the cell and execute with Shift-Enter. And now I'm going to use that built-in type function and then surround the name of my variable by parentheses. And Python tells us that this type is dict, which is short for dictionary. This is a specialized Python type that is extremely useful, actually, and you're going to hear more about that in a later lesson today. All right, in the next exercise, we're going to look at ways to convert between a couple of different types. So given that var2 equals 1 point, and var4 equals 1 in quotes, explain what these built-in functions float and stir do. So I'll go ahead and define these variables that were shown in the problem statement. So first, for number 1, let's look at the float function. So if I type float parentheses var4 and I execute that, can see I get back this value 1.0. Now, var4 was defined as 1.0 in quotes, so it might not be immediately obvious what has happened there. But if let's take this entire expression, float var4, and let's pass that into the type function to see what type we are getting back. So I'm going to type type parentheses, and then I'm going to paste the entire expression float var4 as the argument to type. And if I do that and I execute it, you see that I get float back. So even though var4 started out as a string, the float function takes that string and tries to convert it into a float number. That's what we've done. And then by analogy, I can use the built-in string function str, and I can pass var2 to that and execute that. And this time we get 1.0, but you can see that there are quotes surrounding it. So it has taken what was a floating point number when we declared var2, and it's now returning a string version of that. So 2 more built-in functions that I think are relatively straightforward to understand. All right, and then finally, we have a short exercise here on imports. So you're given 2 code examples here where there is a missing import statement, and then there's a expression that you need to evaluate. So the exercise here is figure out what needs to go in each import statement so that the code will execute successfully. So I'll pause and give you a minute to consider that. All right, so I'm going to copy this first expression here, and I'm going to copy it and paste it without the import statement and try to execute it. And if I do that, you'll see we get this name error. Python complains that this name OS is not defined. Now OS is in front of this getCWD function here. So that's a clue that that is a module name, and we need to say import OS so that Python can find this function. And if I import OS and then I execute this statement, now we have the output that we expect. This tells me what the current directory is. All right, and the second example follows a very similar pattern. I'll paste that here. So in this case, the function that we're trying to execute is this sqrt, or square root function. And you can see that the module name here is math, very similar to the example that we went through during the lesson. So here we need to import math before we can execute that. So hopefully those are some, hopefully each of those exercises were relatively straightforward and start to motivate some of these concepts of different types and different variables in Python. So now I want to move on and talk about some additional types that are a little bit more specific to Python, lists and strings. And we're going to introduce some new notation and concepts here. So I'm going to clear out my notebook so that we can start fresh. So beyond strings and numbers, Python has a type called a list. And a list is a type that's intended to store a collection of objects or different values. So for example, I could define a variable called myFriends, and I can make that a list by using square brackets. So I could just execute this statement as is, and I have created an empty list. If I call type on myFriends, and I'm taking advantage of tab completion here to save myself a little typing, you can see that the type of this is indeed list. Now, in reality, I do have some friends, so this variable shouldn't be empty. So let me add a couple of items. Let me say that my friends are Joey and Rachel, and I'll execute that. So I've now created this list variable, and it has 2 items in it. I can use a built-in function len, which is short for length, to retrieve the number of items that I have in my list. If I say len my friends, and again, use that tab completion, it will save you lots of time. If I execute len of my friends, I get back 2, showing us that we have 2 values in our list. Now, lists can store heterogeneous types of variables. So in the example here, both elements of the list were strings. I'm just going to paste this same statement again. But I could add an element to this list that is an integer or a float, and that's not a problem. Python can store a list that contains several different types of data. Now, Python gives us some very nice ways to access information from lists, and that's called indexing. So given that this 4-element list is our variable, suppose that we wanted to get just the value of the second element. What I can do there is type the name of the variable, my friends, followed immediately by square brackets. Now this time the square brackets aren't defining a list, but they're rather letting us specify an index. So I have my friends followed by square brackets, and then I pass a number. Now this number corresponds to the position in the list whose value we want. And it's really important to remember that in Python, everything starts from 0. So if I look at my list here, this is position 0, Joey. Rachel is position 1. This number 1 is position 2, and so forth. So if I execute this expression, my friends at index 1, I get the value Rachel. I can use a similar syntax to get a range of values. So we again type the variable name, we type our square brackets, and then we type 2 indices separated by a colon. So here I'm going to say 0:2, and I'm going to execute this statement. And you can see this gives me the first 2 values. So what I've retrieved here, what I've told Python to do is give me the values of my friends at index 0 up to, but not including, index 2. That's why we get those first 2 values. Now, if I were to pass an index to this list that doesn't exist, for example, if I say I want the 10th item in this list that only has 4 items, I will get an error, and that's called an index error. Basically, that's saying you've asked for a position that doesn't exist in the list. Now, one of the nice things about a list type is it is what we call mutable, meaning that you can change the values of some of the positions or some of the elements in the list after you've created it. So just for a refresher, I'm going to show the current value of my friends here. Now, I added these couple of numbers to the end to show you how lists could be heterogeneous, but I don't really want those in a list of my friends. So if I want to remove those, I can use something called the del statement, short for delete. So if I type del space, and then I specify an index in this list or a position. So I say my friends, let's say I want to get rid of this last value. So that's index 0, 1, 2, 3. So if I del my friends and I enclose 3 in square brackets, I execute that with Shift Enter. Now I don't get any output, but what Python has done is removed that last item from the list. If we look at the list again, we can see that indeed it is now missing that last element. So we've deleted it. Now I still have one number left that I want to get rid of. So let me do this again. I'll type del, my friends, but I'll use a different indexing trick. If I pass a negative number to the index, we count backwards. So if I specify -1 as an index on a Python list, that gives me the last element, no matter how long my friends is. And if I look at the variable again, we can see that we're back down to just 2 items here, Joey and Rachel. Okay, now there's a couple of ways that we can add items to our list as well. And we use built-in methods called append and extend. So let's say that I'm looking at this list and I realize, oh, I forgot my friend Ross. He should be in the list as well. Well, if I wanted to add that, I can type the name of my variable. I type a dot and then append. And I open parentheses. Now append here works just like a function. It has a name, you pass arguments in parentheses. But we refer to this as a method because it's attached to the variable my friends. So you can't call append on its own. You have to call it from a particular variable. And so if I pass another name as an argument to this append function and execute that with Shift Enter, and we look at our variable again, you can see that I've added another name to the list. All right. I'm going to make the font a little bit smaller there, hopefully, to make it easier to see. All right, now there's one other way to add items to a list. What if I want to add multiple things to this list at once? Maybe I make some new friends and I store those in another list. And let's say that I have made friends now with Monica and Chandler. Those are my new friends. And I want to combine these two lists, new friends and my friends. I can use the extend method to do that. So I type my friends dot extend, open parentheses. And now I just pass this new friends list as an argument. And now if we look again at our original list, we can see that we've taken both of these items from the new friends list and we've just added it to my friends. So append and extend are both really useful methods to understand for lists. Now, I want to cover two more things before we go into a couple of exercises. So let's say that we wanted to modify an element in the list in place. So let's say that my friend Joey actually goes by Joseph now, and so I really don't, I shouldn't be calling him Joey. I can assign a new value to a specific position in the list. So Joey is at index 0, so he's my friend's position 0, and I can just say my friend 0 equals a new string. Let's say Joseph. And execute that with Shift Enter, and we'll look at our list one more time. And now you can see that we've changed that first element to Joseph. So this was a quick overview of interacting with lists. Now, the last thing that I want to mention is that strings can be indexed just like lists. So we've played a little bit with this indexing notation. And if I have a string, I'll define a variable my name, and I'll just type my full name here. I can index that string just the same way. So again, I type the variable name, I type square brackets. If I type one index, I'll get the first character of my name. That's R. Yep, that's right. If I pass -1 as the index, I'll get the last letter, Y. And then finally, if I pass a range, let's say 4 to 9, I will get some of the middle characters from my name here. So I just point that out. This indexing notation is something that's common to a lot of Python data types. And so you really can think of lists and strings in a very similar way. You could think of a string as a list of characters. The one difference I'll note, though, is that a string is what we call immutable, meaning you cannot change it after you create it. So up here, remember, we replaced Joey with Joseph by assigning to this specific index. But if I were to try to change the first letter of my name, for example, to something else, I'm going to get an error. And the error says string object does not support item assignment. So basically what it's saying is that you can't go back and assign a new value to one character of a string. And that's what we mean when we say strings are immutable. Okay. So that was, again, a brief overview of some indexing and lists. Let's switch back to our exercises now. So our first exercise will hopefully reinforce this slicing notation just a little bit. So suppose that we have, we define a variable material as this string carbon, and then we execute this print statement. Think through some different indexing notation here, including this open-ended colon notation, and try and explain what that does. So these are a few extra variations on this indexing that we didn't explicitly cover in the lesson. So I'll give you about 1 minute to just play around with that syntax. Oh yeah, and I should mention that if you're working in this exercises notebook, the easiest way to add a cell is to either use the A or B key for above and below. So if you select, for example, the top cell of this exercise and push B, you will get a new cell right below the cell that you had highlighted. All right, so I'm going to copy the statement here, and I'm going to execute that with Shift-Enter. So in our first example here, we've asked Python for index 1 up to index 3. And so that just gives us these two characters, AR, from carbon. And that, I think, should be pretty straightforward. We covered that in the lesson. I'm going to do a little copying pasting here to save time. So I'll just paste that same line, but let me change the index, and I'm just going to say 1 colon this time. So I provide the colon, but I don't provide a second number. And so here we get everything beginning at index 1. So you can think of the colon as kind of an open-ended indexer. If we reverse that pattern, we put the colon first, and I just leave index 3 as my second, or the ending index, I get the first 3 letters. So this would be index 0, 1, and 2. And so again, in Python notation, the slices go up to the final index, but they don't include it. Now, if we just pass a colon with no numbers, we get the entire string. So this basically gives us the whole list. Now, there's a subtlety here that I'm not going to go into too much detail on. So returning material colon still returns what's called a slice of that string. So it's sort of a separate copy of it rather than returning the original variable. But basically, a colon with no numbers gives you the whole thing. And then finally, let's experiment a little bit with double colons. So if I pass if I pass the index colon colon 2, you can see I get CRO. Now, if you remember, let me just print out our variable again to make this easier to see. So if you notice, CRO is every other letter of our string carbon. So when you use the double colons and then you pass a number, you can get every nth element. And then finally, we'll try a double colon with a negative index. So if I do colon colon -1, we get each element in our string in reverse order. So those are just some of the things that you can do with Python slicing notation. All right, this next exercise is a fill-in-the-blank exercise where your goal is to produce this output that is shown here after first time and second time. So basically, we need this list values to be 1, 3, and 5, and then we need to do something to it so that we print out only 3 and 5. So I'm going to give you just about a minute to think through that one, and then we'll look at the answer. All right, so let's start working with this fill-in-the-blank exercise here. So the first thing I'm going to do is assign an empty list to this variable values. And then you see that we need to do something with the number 1. And if you remember back to the lesson, we want to append that to the list. So if I just execute these first 2 lines, and then we examine values, you can see that now I have a list with just 1 element. So let's just continue this pattern. Let's say values.append 3, values.append 5. And if I now copy this print statement from the example, and I execute that, we've got what we were after. And then for the second part of this, we want to use some kind of indexing such that we only get the last 2 items in the list. So to do that, let me I'm going to copy this code here and fill it in. So we want the last 2 values, and remember we start counting from 0 in Python. So number 1 would be index 0, and then index 1 and 2. So what we can do is just say everything starting at index 1, and then we get what we want. All right, in this next exercise, I want to elaborate a little bit on this idea that you can think of strings as lists of characters. So you're given a couple of example code snippets here, and just play with these for half a minute or so, and try and explain what this built-in function list of a string does, and what this method join does. Yeah, so if I just execute this first line of code, I have a print statement here, print string to list, and then I have this list built-in function that's called on a string. So if I execute that, what you can see is this list function has taken the string tin and it has turned it into a list where each item in the list is 1 character. And then going the other direction, here I'm just pasting this the other line of code from the example here. This time we're using this join method. And you can, if you notice carefully what the syntax is here, we have a string enclosed in quotes here. It's just a dash, dot join. So join is a string method, meaning that we have to call it from a string. And then I pass a list. If I execute that, what you can see is it's taken each element in this list, and then it's inserted that string dash in between each character or each element. So those are two ways of going back and forth between strings and lists. All right, next exercise, I want to show you the sort method. There's a couple of ways of sorting lists in Python. So work through these couple of examples for about 30 seconds, and then we'll talk. So let's start with program A. So I'm going to just copy the code for program A here. Notice that we've assigned to the variable letters, we've assigned a list of the string gold, and then we're calling the sorted function on that list. So actually, I'm going to execute this one line at a time. So letters gives us this list of characters. And if I call sorted on letters, let's see. Oops. You can see that this has just taken the list and it has sorted the characters alphabetically. So you can use that sorted method on a list to do sorting either alphabetically or by numerical value as well, if you have a numerical list. I'm going to skip the second part of this exercise in the interest of time, but I'd encourage you to work through that yourself and take a look at the solution in our solutions notebook. I do want to do this last exercise because I think it gets to this really important idea of mutability. So here are two different programs that are very similar. So let's take a look at the structure of these programs. We start with a list of characters made from the string gold, and we assign that to the variable old. Now in program A, we assign old to variable new, and then we change the character in position 0 of new, and we print new and old so that we can compare them. In program B, we do the same thing, except that when we make the assignment here, we assign a slice of old using that colon notation. And I'm just going to execute each of these in sequence so that you can see the difference. So this is program A, where when we make the assignment, we assign the entire variable old to the variable new. And what you'll notice in the output, this left-hand output is the variable new, the right-hand output is the variable old. Now, this can be confusing because here in line 3 of the program, we only change the first character of new. So why did old change? But this has to do with the fact that lists are a mutable type, and when you make this assignment of old to new, you're really just telling new to point to the variable old. So in effect, they are the same thing. If we wanted to avoid this behavior, we should use program B. I'll just copy that and execute it here. Let's look at the output first. So here we have the same output on the left for new, but old is still the original list, and that's what we want. The reason that this worked better is that when we made the assignment, we just assigned a slice of old to new. So we use that single colon notation. This essentially makes a copy of the contents of old and assigns it to new. So it's very important to understand that difference, and I don't expect that will be totally clear right now, but I think as you learn more about Python, you'll encounter unexpected behavior because of subtle things like this. So over time, this is important to understand. All right, Finally, I want to talk about for loops. So I'm going to clear out my notebook again. Restart my kernel so everything is nice and clean. So for loops are an extremely useful construct in Python, and the syntax for a for loop is the word for space some loop variable, so that we can make whatever name we want here, in, and then some iterable, which for today, or for this example anyway, let's just use a string. I'll say my name is Ryan. So for loop is a way of looping through each element of, in this case, a string, or this can be a list, or in general, something, anything called an iterable in Python. So again, the syntax is for variable in iterable, and then you type colon, enter, and you'll notice that the notebook automatically indents by 4 spaces. Now, in most text editors, this happens automatically. You don't have to worry about it, but Python is very sensitive to the number of spaces. So you have to be indented by 4 spaces in order for Python to recognize what comes next as part of this for loop. So for this example, I'm just going to say for every item in this string, print the item. And if I execute that, you can see that on each line here, we get 1 character of my iterable. My name is Ryan. And that works the same if you have elements of a list. You can also use a built-in function called enumerate, and that gives you both an index and the value from your string. So if I copy and paste this same code from this example, this time I'm going to surround my iterable in this function enumerate, and I have to completely surround the iterable with parentheses. Now, enumerate returns 2 values. It returns both the value from this string, but it also returns an index. So I need 2 variables. So for I, comma, letter in enumerate, my name is Ryan. And now I'm going to print both I and letter. I think this is best seen by example. So in this case, because I used enumerate, I get both a position, which you can think of as an index in this case, as well as the actual letter at each string. You can also use something called the range function to iterate through sets of numbers. So for example, if I type for I in range and I pass 2 numbers, 0 and 10, colon, the colon is very important, then for each of those I want to print the number. If I execute that, I will get each number from 0 to 9. And so again, this follows that convention in Python where when we pass indices, we're going from index 0 up to, but not including index 10. You can also pass an additional argument to range if you want to specify, if you want to step in more than one number. So if I just repeat that example, I say for I in range 0, 10, 2, that third argument is the increment. And this time I'm going to get 0, 2, 4, 6, 8. Now we can also put some logic into our for loops. So let's say that this is one way of getting even numbers, but let's say we were interested in only printing even numbers and we didn't want to use that third argument to range. So I could say for I in range 0 to 10, colon. Now I'm going to add an if statement. And you're going to learn a lot more about if statements from Guy in the next lesson, but I'm just going to say if I, and I'm going to use that modulo operator, meaning if basically if I can divide the number by 2 and not have a remainder, then print the number. So for every number in this range, it's going to evaluate this logic statement and then either print the number or not. And if we do that, we also get every even number. All right, the last thing I want to go through before we go to some exercises here is the a built-in function called zip. So if I have two different iterables, so let's just say my name, that's Ryan, and let's say my list, and I'm just going to create 4 numbers for that list. I will create both of those variables. So note, one of these is a string, one is a list, but those are both considered iterable types in Python, meaning that we can loop through their values. And you'll notice that they both have 4 elements. I can write a for loop with 2 variables. I'll just say for I, j in zip. Now the built-in function zip takes 2 iterables. And so you can think of it like a zipper. It puts the 2 iterables together and gives you the value from each. So I'm going to say my name and my list, and I want to print I and j, where I is coming from my name and j is coming from my list. And if I do that, you can see that Python is taking both of these iterables, and it's returning 1 value from each on each loop. All right, let's switch over to some exercises now in the last few minutes that we have. So one of the very common uses of for loops is to compute a running sum. For example, the sum of all of the squares from 2 to 11. So this is our first exercise here. So take about a minute to ponder how you might do that. I will give you one little hint here that we didn't cover. If you have a variable with some value and you want to update that value, you can use a plus equal, which basically takes the current value and then adds the value on the right. So I'll do this a different way actually. If I start var with value 1 and then I plus equal 2, I will get the value 3. So plus equal is a very useful part of that exercise. So consider that and just take a minute to work on that. All right, so let's discuss this example here. So typically when you want a running sum, your first step is going to be to create a variable to hold that sum. So we'll just call that variable s, and we'll assign it the value 0 to begin with. Now we want all of the squares from 2 to 11. So we could say for I in range. Now we could say from 2 to 12 here. And then we can use that plus equal operator, s plus equals. And so we need the square. So we'll just say I squared. And then when we're finished, we will print s. So that's one way of solving that problem. All right, in the next exercise, given this list of friends, we want to write a for loop that prints each item in the list, in this case each name, but stops when it encounters the 3rd value. And this involves the use of the break statement, which is something that we didn't talk about yet. So I'm gonna walk through this exercise in real time here. So first, let's create our list. Shift Enter. So first, let's just write a for loop. Now, we know that we need to do something based on the position that we're getting, right? We know we need to stop our loop when we get to the third value. So because we need to be aware of the position that we have in the list, this is a good time to use enumerate. So I'm going to say for I, comma, friend in enumerate friends. So this means at each iteration of the loop, I'm going to get an index, and I'm also going to get the friend's name. Okay, so as a first, this isn't the solution yet, but as a first go, I can just print the friend's name. Okay, that works. But now we need to figure out a way to stop when we get to the third element. So this is where we're going to introduce a little bit of logic. And again, this is something that you guys are going to hear a lot more about in the next lesson. But let's say if I is equal to 3. So I is that index that I'm getting back from enumerate. If I equals 3, I'm going to tell Python to break. Now break is a statement that tells Python to stop the loop. It just immediately ends the iteration wherever, at whatever point it is. So now that I've put this logic in this break statement, if I, here, I'm gonna copy and paste this cell so that you can compare the output from the previous version. So that's what we had before. So you can see this time, when I loop through this list, I stop after printing the name Chandler. And that's because Chandler is at index 2. So our I value would go 0 for Rachel, 1 for Monica, 2 for Chandler, and then it hits 3, and the loop stops. All right, and then finally, our last exercise for this lesson, explain what happens if you were to call zip on two iterables that have different lengths. So let's just define a couple of strings with different lengths. We'll just say, we'll assign captain is equal to Kirk and officer is equal to Spock. Shout out to the Star Trek fans out there. And then we're going to write a for loop using zip. So I'll just say for a comma b in zip, and I'll pass these two different iterables. And I'll note that these are different lengths, right? Captain has 4 characters, officer has 5 characters. And I just want to print each one. So if we do that, you can see that zip will continue iterating until it reaches the end of the shortest iterable. So captain was shorter than officer, so we get all the characters in captain, but we don't get the last character of our officer. And then there is a final exercise in here, which I'm going to leave as a bonus exercise. It's a little bit more advanced and it might take a little more time. So for the curious, I would encourage you to work through that on your own time. And we do have a solution available in our solutions notebook. So I hope this has been a helpful introduction to some of the really foundational concepts in Python, like expressions and variables, types, lists, indexing, and those sorts of things. I think you're going to find yourself using each of those ideas in the lessons that follow.